So the constant function is just a function where there are no variables. It's just a number. If it's just a number, what would that graph look like? If it's just like y equals 2, y equals 7, y equals -6. So it's just going to be a horizontal line. So linear function is a straight line. Constant function is a horizontal line. Two other types of parent functions that I want to just at least mention and talk about are the power function, which is f of x equals, I'm going to say x to the n. And this is specifically if n is greater than or equal to 2. So like your x squared, x cubed, x to the 4, x to the 12. We're not going to do an x because then that's our linear function, or x to the 1. So if n was 1, then that's just linear. We want to look at ones that are not linear. And then the graphs of these are going to change depending on whether you're, like what n is equal to. So if it's even, it's going to be like a U shape. If it's odd, then we've got something like that shape. And then the root function is something like f of x equals the nth root of x, which I could also say is x to the 1 over n. And then n, I'm not necessarily going to write it here, but it would need to be an even, or not even, an integer greater than or equal to 2. Okay. So these are just our basic, just some basic functions. If I want to graph them, we can plug numbers in for n, or for x, and then just see what those look like. Double check. Okay, so what we're going to look at now is we're going to say, well, what if I just give you some random function, some random equation for a function? How do we graph that? Actually, I just realized there's actually 2 more types of functions that I didn't put on here. Because we had your linear function, power function, root functions. I actually put 2 more types of functions on here. We have a reciprocal function. This is where it's just something like f of x equals 1 over x to the n. And then the last one I want to look at right now is we have an absolute value function. Which is where I have just like f of x equals the absolute value of x. So these are just some various just types of functions. If you want to look a little bit more about what their graphs could look like, you can look on page 202. I'm not necessarily going to put them on here, but if you want to look at them, page 202 has just some examples of what they can look like. There is like the greatest integer function. We're not necessarily going to do too much with that one, so that's another one. But these are ones that we're going to be working more with. Okay. So those are just some basic functions. You can look at page 202 and kind of see what do those graphs look like. What I want to focus on a little bit more in this section is if I give you just some equation and I want to know what does that graph look like? What are some ways that we can graph? So in this section, graphing is just going to be done by making a table. We're going to plug in numbers for x, plot them, see what the graph looks like. When we get into additional sections, that's when we're going to start looking at transformations. We're going to do vertical and horizontal shifts. We're going to do reflections. We're going to do stretches and compressions. So the first graph, so we're going to graph a bunch of functions. So I'm going to say, for example, we want to graph each function. So we're going to do 3 or 4 of these. So we're going to start simple. And say, let's go f of x equals x squared. Before we graph it, can someone tell me what the shape of this graph is going to be? It's going to be your parabola. But let's say we didn't know that was going to be your U-shape, your parabola. One way, if you ever have something that says graph it and you have no idea how to graph it, plug numbers in for x and y. I like starting with -2 to 2. And then if you need to add more numbers anywhere else to fill in what the graph looks like, you can. But -2 to 2 is kind of a good starting point. A lot of times they can give you an idea of what the shape of the graph is going to be. Okay, so if I plug -2 in, -2 squared, what is -2 squared? Is that going to be a positive or a negative? It's a positive. So just make sure if you square a negative, it becomes positive. So I'm going to square each of these numbers. -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. Which is kind of what we would expect. And then if I was to go and graph this, that was not what was supposed to happen. There we go. Got -2 squared is 4, -1 squared was my 2, or 1, 0, 1, 2. There is that graph, which is what we expected it to look like. One thing when you're doing things like on homework or whatever, if you don't want to draw out your own graphs, I do have over here on the counter, I have a bunch of either graphs that are like cut out already, or I have sheets of just blank graphs. So if you ever just want some blank graphs, I've got a ton over here on the counter. You're welcome to grab whenever. So if you don't want to have to draw your own graph as we're working through things. Okay. Any questions on the parabola? So this one right here is just, I feel like, relatively simple. We've been looking at parabolas since secondary too, so it's been a little while since we started doing those. This next one's going to be one where it's going to be a little bit more than just a single parent function, be a little bit crazier. I'm going to do something like f of x equals the absolute value of x. And then from the absolute value of x, we're going to subtract x.
1v1 minus x.
And then we're going to see, what does this graph look like? So once again, if you don't know how to graph something, creating a table is a good way to start. So I'm going to say, here's my x. To find my y, I'm actually going to say f of x here just so we know we're going to be plugging those in for x. So again, -2 to 2 is a good starting point. So I'm going to replace each of my x's with the -2 to 2. So if I replace the x's with -2, absolute value of -2 minus -2. What does an absolute value do to, makes it a positive. So this is +2. Subtract a -2, what does that turn into? Turns into a plus. So we have 2 plus 2 is 4. Oh. Good morning, Jonah. I will get you a textbook after we're done with this. Just come in and take a seat. Okay. So let's do the same thing again. -1. -1 minus -1 becomes 1 plus 1, which is 2. Absolute value of 0. What's the absolute value of 0 equal to? 0. Okay, we're going to go the absolute value of 1 minus 1. Gives me a 0. Absolute value of 2 minus 2. 0. So no matter what positive number we plug in, what is the answer always going to be? 0. So when I graph this, with the negative x's, the graph is going to change, or the y values are going to change.
Pardon the interruption. Is Justin Navarro there?
Yes.
Can he come to the Student Center, please?
Yep.
Can they come to the Student Center? Thank you.
Yep. Okay. So when I graph this, we have -2, 4, -1, 2, and then 0. So this is the left side of the graph. The left side of the graph ends up being a line with a slope of -2. The right side of the graph, what's going to happen when x is positive? What is every single y value going to be? 0. So this graph is going to do something
That's also like a triangle.
like that.
Never ends. We're like a triangle.
Okay. So if it's something crazy where it's not just like a regular parent function, plug numbers in for x, see what the graph looks like. Okay. So there's 2 more things that I want to look at with graphing a function. Okay. So for C, I'm going to just go f of x equals 2 minus 3x. But I'm going to say that I want this to go from -2 is less than or equal to x is less than or equal to 2. So I could make a table to graph this, but what do we know? If I just at least look at this right here, what do we know about this graph? What kind of graph function is this? I have 2 minus 3x. What is that graph going? What's that going to look like when we graph it? What shape?
A triangle.
So what if I rewrote it as this? It's linear. What's the slope of this line?
-3.
And then my y-intercept is 2. So I'm going to graph it, but am I going to graph everywhere? Am I going to draw arrows on both sides? Well, what is...
No, because there's that.
Because there's this thing right here.
You draw circles.
Rain.
Fill
Yeah, so this is our domain. We're gonna do filled in circles between -2 and 2. So you could make a table on this. I think this is what this section is thinking that you're going to do. Or I need something like this. I can say my y-intercept I know is going to be a 2. And then it goes down 3 over 1. So down 3 over 1, down 3 over 1. And then I'm just going to stop when I get to 2. Do the same thing, go left 3, up 1. I didn't make this go high enough. I'm going to have to make that a little bit. Go up to 8, left 3, up 1. And then I'm just going to graph, oh, not up to, that should go to a 5. There we go. And then we're just going to graph between these. So we're not going to draw arrows at the ends. We're just going to graph this. This right here is my domain. So I could tell you a specific domain that's just saying graph between these two x values. Okay. So the last thing that we're going to look at, we're going to look at a piecewise function. Or at least for this little piece. And then we're going to talk about what does it mean if something is a function, if a graph is a function. And then we'll talk about, we'll do 2.3. So the last graph we're going to do right now is f of x equals, this is going to be a piecewise function. I'm going to say it's x squared if x is less than or equal to 1. And then I'm going to say, let's do, what do I want to do there? 2x plus 1 if x is greater than 1. Okay, so I'm going to start by graphing this x squared. We already did x squared at the beginning. We saw if x was 0, y was 0, x was -1, y was 1, x was -2, y was 4. We only want to go where x is less than or equal to 1. So I'm only going to go over to x equals 1. And then what kind of circles should I be putting right here? Kind of circle. We're going to do a closed circle because we have the equal to. So when x is less than or equal to 1, this, we're going to have your x squared. When x is greater than 1, we're going to be graphing 2x plus 1. So this is going to be my line with a slope of 1 or slope of 2, y-intercept of 1. So it would start at 1, but we don't want to actually graph the first part. It starts at 1, up 2 over 1. And so my first point is actually going to be up here at 3. Or what kind of circle am I going to put at the starting point of the line? Is it going to be a closed circle again? No, we're going to do an open circle. So open circle, and then up 2 over 1, up 2 over 1. Draw that line. So we could have made a table to do some of these or just use what we know, except for I didn't do that high enough. I said up 2 over 1 and then I only went up 1. It should have actually been right here. So it should start at the 1, up 2 over 1. I just put that first point in the wrong spot. Okay. Any questions on drawing a graph? Once again, if you don't know what to do, just plug numbers in for x and see what happens. So the last thing from 2.2 we're going to talk about is what is the definition of a function? What does it mean if something is a function? So this is where our good friend, the vertical line test, comes into play. Someone remind me, what is the vertical line test? What does the vertical line test tell me?
Put a vertical line on a graph
Yeah. Yeah, so if I look at a graph, I have this graph right here. Is this a function? No. And why is it not a function? Yeah, if I draw a vertical line right here, this is not a function. But if I give you a graph, something like this, just make up some random thing. Is this a function? Yes. Okay. So we've got our vertical line test. If I give you a graph, just look at it and see, does it cross more? Does a vertical line cross it more than once? Okay, so the last thing from 2.2 is we're gonna, if I give you an equation without a graph, we're gonna decide, is it a function? So remember, the definition of a function says that each x has exactly one y. So what I'm going to do is I'm going to actually go and, if I give you an equation, we're going to solve for y and see what happens. So for this first one, I'm going to say y minus x squared equals 2. So I want to get y by itself, and then we're going to see if we have more than one y value if I plug in a single x value. And we'll see quickly what that means. So if I plug in, or if I solve for y, this would just be adding x squared to both sides. This is really y equals x squared plus 2. So for every x value we plug in, how many different y values is this going to give me? If I choose just any random x value, is it going to give me more than one y value? No. So this is going to be, so for this, each x has one y, which means this is a function. What is the shape of this graph? If I say I want you to graph this, what would the shape of this graph be? It's a parabola. Which parabola we know is going to be a function. Okay, so parabolas are functions. Any questions on A? So for B, I'm going to look at this one. X squared plus y squared equals 9. Does anyone know what this graph is? If I graph it, what this looks like? What was that? So it's not necessarily a squiggly line. Let's maybe solve for y, and we can kind of, I don't know, maybe get... Did you say something else? Okay, making sure I'm not ignoring. Okay, so let's solve for y. So to solve for y, I'm going to subtract x squared. So this is 9 minus x squared. And then what do I need to do to finish getting y by itself?
Square root.
Square root. So I'm going to take the square root of both sides. But when I take the square root, what do I have to do over on the right side? So just the square root? Or is it... Good morning, Brayden. First period is not the same anymore. He is not here. Okay. So I'm going to do plus or minus 9 minus x squared. And then, so if I'm looking at this, for every x value you plug in, how many different y values is it going to give you? So if I plug in x equals 1, how many answers do we get? 2. So for this graph, each x has 2 y values. So is this a function? Oh, so this is not a function. So it ends up that if I graph it, it's going to look something like this. This is going to be a circle, which you guys did in secondary 2. I know you listed a little bit. I think you did stuff with the equation of a circle. This is a circle centered at 0 with a radius of 3. Pretty sure that's in secondary 2 you do. Maybe they don't. I don't know. At some point, this was something that was taught. Secondary 2 extended, I know for sure, does that. But anyways, any questions on graphs? Okay. So we're going to look at real quick 2.3. 2.3 is pretty short. So 2.3 is getting information from graphs. Okay, give me just a second. I need to pull up a graph real quick. Okay, so I'm going to put a graph on here. This is the graph I'm putting on here. This is on page 206 in your book if you wanted to look at that. So this is looking at the temperature. I'm actually not sure what the x values represent. I'm guessing over time, over some maybe days, over minutes, over hours, probably like hours, I'm guessing is what this would be. But maybe over days. I actually have no idea what the units are on this. So if I gave you this graph and I said, what is t of zeros? Where would I look on the graph to find t of 0? So we're saying x equals 0. If x equals 0, what does y equal to? 15. So t of 0 is 15. What if I said something like, where is t of x equal to 25? Is this 25 an x value? Is that my input? We look on the x-axis for 25. Where do I look for that 25? So I'm going to look on the y-axis. So I'm going to say, if y equals 25, what is x equal to? How many answers are there? 2. So we have x equals, about right here, 1, and x equals 4. Any questions on these two? Okay. And then the last thing we're going to look at from just evaluating a function from a graph is I could say something like, where is t of x greater than or equal to 25? Is it just going to be a single x value? It's like x equals 7, x equals 3. Is there just a single x value? No. So it's this whole section right here. So if it's like a big section of the graph, this is where we're going to write it as an interval. What two x values did we say it's equal to 25 at? Was that 1 and 4? So is it between those two numbers or is it on the outside of those two numbers? It's gonna be between. So I'm gonna say let's start at 1, end at 4. I'm gonna do close brackets because we had the equal to right here. If it was just greater than 25, we would do the parentheses, but since it's equal, do your close brackets. Okay, so in 2.3, we're evaluating functions from a graph. So I'll give you some graph. It could have a context. It could just be some random graph. Any questions on evaluating functions from graphs? Okay, so the next thing we're going to look at is, well, what if I want to find the domain and range? So I'm going to draw a graph up here. So I got 1, 2, 3. So I'm going to start at 1, and then at 3 it's going to go up to 2, at 5 it's going to go back down, and the graph's going to do something like, I don't know, like that. So this is my entire graph. I want to know what is the domain and what is the range. So the domain is your X. Range is the Y. So what is my smallest X value on this graph? What's the smallest X value? 1. What's the biggest X value? 5. And because I didn't draw an open circle on those, we're going to do square brackets. And then for the range, so close. What's the smallest Y value? 0. What's the biggest Y value? 2. And because I didn't have any closed or open circles there, there's no asymptotes, everything there is going to have square brackets. Okay. Questions on domain and range from a graph? Okay. Next thing we're going to look at is where is a function increasing and where is it decreasing. So increasing is where is the graph going up. So I like to think about it as going the same direction as a positive slope. So here's some random graph. Increasing would be something like it's doing this direction. So same direction as a positive slope. Decreasing is where it's going down. It's where is it going the same direction as a negative slope. So if my graph is like, it could be curved, it could be something like that. It's going the same direction as a negative slope. Okay. So we're going to look at an example. I'm going to draw a graph up here, and we're going to find where it increases and where it decreases. Okay. So just I'm going to look at this graph. So this is going to start at -1. So we have a point at -1. Let me label these. Starts at -1, 2. And then I'm going to put another point at 1, 3. I'm going to put another point at 2, -1. And then another point at 4, 2. And then I'm just going to connect these. It's going to go do something like this. So there's that graph. So if I ask you for an interval where a function is increasing or an interval for where the function is decreasing, I am always asking for input values. So I say, well, where is it increasing? We're going to look at the x values where the graph goes up. How many different places on this graph is it going up? There's 2 places. So we're always going to list your x values. What x value does it start going up at the first time? So it starts going up at -1. Okay. Where does it stop going up for this first section? 1. So we need to decide when we're doing this whether we do parentheses, whether we do square brackets. At this very beginning, so I'm at this starting point, have we started going up? So in order to be going up, you have to be going from somewhere lower. Is there anything that we're coming from that's below? No, so I'm going to do parentheses there. What about when we get to the very top? Are we still going up when you get to the very top? No, have we started going down yet? No, it's like you climb up a mountain, you climb to the very top, you made it there, you got to take a break, you got to eat your granola bar, you got to take some pictures, you got to enjoy the view. So, I'm going to do a parenthesis there. Was that the only place that this graph increased? No. Where's the second place that it starts increasing at? 2, and where does it stop increasing? 4. Once again, I'm going to do parentheses, and then because there's multiple intervals, this is where we put the U, that union in the middle. Okay. Any questions on increasing? Okay. And then for decreasing, this is just the opposite. Where is it going down? How many different places do we have on this graph where it's going down? Just 1. So between what 2 values? 1 and 2. And then do parentheses on those as well. So increasing and decreasing always gets parentheses for your interval. Okay. Questions on that? So now the last thing that we're going to look at is a local maximum and local minimum. So local maximum and minimum values. So I'm going to draw just some random graph. I'm not going to put any X or Y values on it because I don't really care about those for this graph. So here's just some random graph. Where do you think I am looking if I'm asking for a local maximum? How many local maximums do you think this has? Has 2. So the local maximum, these are the peaks of the graph. So that's the way that I kind of think about it. It's where is it? Where's the highest points? There's a local maximum here and a local maximum here. How many local minimums does this have? This has 2 as well. The local minimums are your valleys on the graph. So it'll be here and here. These are your local minimums. So if I ask you for a local max or min value, this is going to be Y values. So I'm going to say, if I say, what is the value of your local maximum? You're going to tell me what is the Y value. But then I could also say, what is the X value where the local maximum occurs? So if I ask, if you do an X value, it's because I'm asking you where is the X value where the local max occurs. The local max and the local min themselves are your Y values. So even though this point right here is not the highest point on this graph, if I zoomed in and I said, well, let's just look at this mountain range right here. That's the highest point on this mountain range, as opposed to looking at the whole thing. So for example, if we're thinking, okay, there's some tall mountains around us. They're not the tallest in the state. Like we've got Lake Mountain over here it's not the tallest around, but we can say there is a high point there when we compare, I don't know, are those the Okra Mountains? Whatever mountains are over there are even taller than what we have to the east. That doesn't mean that we don't have mountains. Even if it's not the highest mountain, it still is a mountain. Even if we have a hill, if it's not, we don't want to call it a mountain. It's just like a little hill. That still could be considered like the highest point in its little area. Any questions on any of that?